first problem that will arise? In this scenario, for the tester, what is the first problem you think?
Environment change.
Exactly. From a testing perspective, the first point this person would say is app is not working. It will not work. This is because the server has changed. The environment has changed, right? Here there are different computers. Here there are different computers. It could be different OS levels, different softwares, different levels of those softwares. There could be so many different dependencies, which will impact the execution of the application. So environment is changing. So that means the application has some dependencies, and because of which it doesn't work in test system. Right? So to overcome this, if you remember, I was talking about virtualization, right? When I was talking about the VM machines and all the Dockerization and all that, I gave an introduction to virtualization. So what virtualization does is, it takes the status of these servers or server, right? Probably all of these are put in one server. So I will basically templatize it. That means I'll create like a snapshot. The status of this entire server will be saved. It's like I take the entire server and then try to put that into a different machine, virtual machine. Right? It's like all the dependencies, entire this computer is put in a different computer, right? So that is templatization. But when you do this, there are certain problems. Okay. The problem is, with respect to virtualization, the hardware consumption would be a lot. Right? So this is the scenario, guys. Hope you have got a big picture on what exactly this is and why it is required. Right? So we are doing virtualization. Okay. So let me erase this. So in virtualization, what happens? So let's say I have a server. I'll draw the memory here. Let's assume that I have a memory. This is RAM memory, which is, let's say, 16 GB. It's a very big server. Okay. Now, the templatization that we have done, right? That the template that we created with respect to the development environment has to come in. So we will have, let's say, first tester. For this person to test the application, we will have to create a VM. I'll say VM1. Virtual machine. So that means there are some components, some resources which are getting allocated here. We'll talk in terms of memory. So this virtual machine, let's say, is created with 6 GB. Okay. So out of the 6 GB, this is a computer now. So you're blocking 6 GB of memory out of 16 GB to this machine, which is physically not there, but virtually we are creating so that we can give access to the tester. Now let's imagine the application that is there is actually requiring, let's say, 4 GB memory. The application is requiring 4 GB. So that means 2 GB is idle. This 2 GB is not used. Then I have another tester. For this person also, I'll have to create the application. Okay. So let's say here the virtual machine 2 that we are creating, maybe I've given very small resources. So I will say 4 GB so that I have 10 GB covered. For this virtual machine, I've given 4 GB. In this 4 GB, let's say 1 GB is wasted, not used. That means 3 GB is used. With respect to the server, when you are testing, only 4 GB is 3 GB is used. Let's assume that I have another person. The remaining 6 GB memory, I'll create another virtual machine. Assume, only from theoretical perspective, assume that we are using another 6 GB memory. So total 10 plus 6, 16 GB memory is used. So let's say, again, same like this, maybe 3 GB is used, 3 GB is free. Okay. So this is free. So if you add out of 16 GB, how much of the memory is actually being used? 4 plus 3, 7, 7 plus 3, 10 GB is used. So that means the remaining 6 GB is wasted, unused. Now, if you would have used the resources appropriately, the consumption, right? The consumption would have been appropriate, then the performance of the application would also have been very good. This is the biggest problem because you are trying to split the physical server into virtual machines. They are independent computers. So they are independent machines, though virtually, but independent machines are created, and we will have locks. The resources are dedicated or locked. Now, if we use the alternative approach, which is, this is one of the solution. This is solution 1, which is virtualization, which is used to solve the problem of testing the applications. We are basically trying to ensure that there are environment dependencies are not hindering the testing process. Now, in Docker, what we do, Docker is not a physical right partitioning. It's more like a OS level containerization, right? I mean, OS level we'll try to split. So let's say I have the same server, and it is also having, I mean, same server, right? So it has 16 GB. Now, Dockerization is basically an application level partitioning that we do, application level splitting, right? So we create containers. That's what Docker allows us to do. So let's say I have container 1. Okay, this is app 1, the same app, but I'm creating this as first app. Let's say I'm assigning whatever memory I wish. Okay, so let's say I'm assigning the same whatever memory is used, right? 4 GB is used. So I'll only assign 4 GB memory for this application, and all the memory will be used because there's no operating system. It's just an application. Similarly, I'll take the second app, I mean the same app, second container I'm creating, and here I'll create 3 GB. And here I'm also giving again 3 GB because that is what used here, right? So I'll only try and give that particular memory. So now you can see out of 16 GB memory, we are using how much? 10 GB memory, which is allotted. But even after giving this 10 GB, we still have 6 GB to be used. That means we can create more applications. You can create more containers. Right? So that's the logic here for your Docker system. So when you try to compare the solution 2, which is containerization using Docker, there are a lot of advantages that are brought. We have seen the comparison between Docker and virtualization, if you remember. So when we talk about a virtual machine, and both have every technique has its own advantages and disadvantages. It's not like only disadvantages are. The primary difference between the Docker and virtualization is in virtualization, you can have your own operating system, your choice. The guest operating system that we talk about, you have your own option. Whereas in Dockers, which basically is containerization, here we will have same guest OS. For application, you'll have only one operating system. Because operating system is not an option, these are lightweight. We call them as lightweight containers. Okay. Whereas here, these are heavy weighted. They're weighted basically a lot. In basically the containers that we have, right? We will always use Linux operating system only. Okay, same guest OS, that operating system would be Linux operating system. Okay, that's also something that you should remember. So because these are heavy machines, right? Virtual machine, isn't it? So we are creating a separate machine. Though you have a choice of creating your own operating systems as per your needs, it requires more memory, right? Disk space, memory, right? So on the host server that we are using, we will be physically demanding for certain resources more than what we use here in Docker containerization. Docker uses less memory, obviously, right? You don't have operating systems and all that. It is very lightweight. Only application is there. Now, because it is a separate machine altogether, when you want to start up, when you want to boot up, this is time consuming. This is like flash of a second. It boots up in flash. It's only application, not the operating system is there, right? So it doesn't even have a glitch, just ready to use. Okay, so that is the boot up time. This is hugely different. Docker is super fast. Okay, and thereby the performance, obviously, because it's not a heavy, performance also is going to be better when compared to your virtual machines. From setup perspective also, Docker is easier. Right? All you need to do is bunch of commands. That's all. All you need to have is a Docker software and bunch of commands which builds and saves and pushes your Docker image. And when you want to use that, you just try to run that particular image so that a container is created. A container is nothing but a runtime instance. We call it as a runtime instance. It's like you have an image, take a snapshot image, and then you use that image for your operations perspective. So when you want to activate it, that's when you call it as runtime instance, right? You trigger an image to a container. Next. The Docker container has OS independence. Right? That is another beauty. You can take that image to any platform. All you need to have is just the Docker software installed. That's all. Right? Whatever the containerization software that you probably want to use, you need to have only that software. And irrespective of OS, it's going to work. Right? So these are some of the benefits. So you basically talk about less resources usage here. You'll see that it is fast, right, and independent of platform. Specifically, OS is what we talk about, independent of OS platforms. Right, so that is the containerization advantage when compared to virtualization. Next. Now, as we talked about some of the advantages of the Docker with respect to the setup and at a high level, right? We'll also talk about that as a developer, when you try to use Docker, you will be able to build right solutions, or you want to develop some applications, right? Solutions. You will be able to send that, right, as a developer, whatever application or solution that you're developing, you will be able to send it to tester. In fact, multiple testers, right? All you need to have is Docker running on the environment. So you're only taking the application and the dependencies as an image and send that image to the tester. In the testing environment, I mean, their environments, the only requirement is the Docker software, as I mentioned. So when you try to work on this image, we will run that image so that we get a container. This container is basically a runtime instance. We use this terminology. That means your application is ready to use. So we are taking a snapshot of your application and the dependencies, combine everything, and send that image to the testing environment. And in the testing environment, we basically have this Docker, which uses that image and creates a container runtime instance. And once this is created, here, the tester would be able to test the application. So there is no issue of environment dependencies, right? And the further advantages of Docker that we talk about is it is consistent to start with. So as a developer, when you develop the application, right, and once you create an image, that image is fixed and you can give that image to n number of different team members. It will be consistent, right? It will not change unless until you want to update your image, right? So that is one advantage. You will not see that tester one sees different application, test two will see different features in the application, right? So that doesn't happen. There is consistency here. Then they are isolated. Okay, these are completely isolated features. I mean, it is right. Nothing it has to do with other applications, or as we talk about independency, right? So these are something like an individual independent image or containers, and everything that is required for that application to run will be there inside it. So it is not depending on something else, right? There's isolated units. The entire process of deployment becomes very easy. So you will have fast or quick deployment, right? This is another advantage. So you immediately start working as a tester. You give the right, you get the application that you need to test in the image format, and you're going to containerize that, and immediately you will start right, deploying it. All you have to do is create a container and you'll start running it, right? So fast and quick deployment. All right, so that's another advantage. So a lot of things are automated. So you'll have automation achieved, right? And because you are going to work on these applications as an individual entities, independent entities, you'll also be able to achieve modularity. Now, the advantage of modularity means is that you can have multiple sub features developed by different developers as an individual features altogether, and then you bring them together into a single platform, right? Like you're installing multiple Docker containers, and together they'll work as a single solution, right? Microservices, you can basically call them as microservices. So modularity will allow us to break down that entire application into smaller pieces of applications. Right? So that's one advantage. Next, it is portable. Right? That is also another thing that we need to talk about. Irrespective of what operating system the host is using, that is the developer is using, irrespective of that, the container would work, or the image that we are using, right? The container would work in testing environments. Irrespective of operating systems, they work. Right? And the most important thing is scalability. In developers' environment, the application might have been developed in a smaller server, right? It's not highly configured. Hardware is very minimal, for example. But when you talk about testing team, there might be multiple people who are using the same hardware, or same application has to be tested by different testing team members. So in such case, the application requires a lot of resources so that these multiple testers requests can be accommodated. So the application that we are installing can be installed with higher configuration, that there is more memory can be assigned. Right? It is OS independent, it is hardware independent. It's just an application that we are getting. So I can ensure that the application is sitting on a higher configuration environment. So you can scale up, and let's say your development team is big team, but you have only 1 or 2 testers who are basically testing the application. Then you can also scale down, right? So there is a flexibility basically in order to deploy your application. So these are a bunch of additional benefits that we'll have with respect to Docker. Okay. So as a developer, right, you develop this application. There's some application that you developed. Okay. And this has been given to the testing team. So these testers that we are speaking about, there could be multiple testers, right? So it's not just one testing team member that we are talking about. We may have multiple testing team members. So when you're giving this, you have to basically give the image of the application. Right? As a developer, when you are trying to pass this application to the testing team, where you might have multiple testers, you're going to pass the image. Okay, remember that. But if it is not from an image perspective, if it is like a separate old technology where you're just giving the software that you have developed to the testing team, and while this is build 1, let's say this is the first release, but you still have the development cycle. So you further develop, right? New features are added. Some upgradation happened to the application. So I'll say app version 2. This is version 1. Now, again, what you have to do to this testing team, you'll have to pass this application to, and these people have to reinstall, reset up, right? Redo everything. And if these testing team have different systems, all of them have to do the same process again. Right? So the users, application users, it could be testing team, it could be the released product in production environment. So if you have multiple users who are accessing the application, whenever there is an update happening, all the users should get that updated features as well, rather than a manual setup where they try to uninstall this application one, reinstall application two, try to reset up everything. Rather than this process, can we not have an approach where, as a development team, you update your application, offline you test the application, and then push it to the production environment? Irrespective of what is the functional level understanding or technical level understanding of the end users, the application should automatically get updated. That's what we see in mobile applications. If you see, some application features are updated even without you manually doing it. Even without your knowledge, the application gets updated automatically. Right? As an end user, you don't have the headache to uninstall and reinstall it, isn't it? So the application users, a number of users, all of them should see the changes or feature upgrades. Now, manually, you don't want to update each and every application, right, at the end user. Even if you're using this application and containers are created, you don't want everybody's container to get manually updated, isn't it? Because these containers are independent, right? So you don't want the end users to take the pain of updating their end user container machines or container images. You understand the problem? Whether you're doing manually, whether you're using Docker, you basically give the application. And in the end user side, this application that we are using, right? The end user side, we will have the containerized runtime instance created by the end users for using that application. But managing those containers is the question that we are looking at. So if I make some update to my image, then does that upgrade also automatically reflect to all the users? If I talk about Docker level, no. So manually, end users have, all the end users who are applying using that application containers should manually update it. You'll have to convey the message to all the users saying that, hey, I have updated the image. Please refresh or update your container. You're manually conveying the information and people are manually doing it. And this is the problem, managing all these containers. Right? Now, this is where we need container management system. We want some technique which can allow us to do management of containers. And of course, you also, once we try and to talk about the maintenance, you also might want to track the performance of the containers, understand the health of the containers, right? All those things, right? Everything, basically from a maintenance perspective and operations perspective. So this maintenance challenge actually triggered a new software called Kubernetes. This was developed by Google, and the development happened in 2014, very recently. It's not that old. A lot of applications that we talk about are from 1990s, 1980s. Kubernetes is a very, very new application, right? So it's 2014 developed application. And of course, Google. Whatever we speak about, right? 90% of the applications that we are going to talk about are developed by Google directly or indirectly. Google's hand is there. Okay, so Google has invested their brain and developed a cluster of container, sorry, not cluster, a container management framework. Container management framework. Because if you have one or two containers, there is no problem. But when you're developing an application, you don't know who all are going to use that application, isn't it? Now, just imagine that you are developing a mobile application and giving that mobile application in the Play Store. So a lot of people in the population, they are using that application. Would you be able to manually manage all of those containers or the applications individually? Not possible, isn't it? So that's where Kubernetes is required. And from our perspective, we are only talking about the application of Kubernetes from a machine learning perspective, not from a software development perspective, friends. But the idea is similar. As you have seen, I have not mentioned that the application is a machine learning model. Okay. So that's Kubernetes. Hope you have now got the fair bit of idea on what exactly is Kubernetes and why we need to use it. But in order to talk about Kubernetes, you need to get that Docker picture clear. There are various components in Kubernetes, the architecture, right? Kubernetes runtime, and how CI/CD pipelines are maintained in Kubernetes. So these are the major agenda points that we will be talking about with respect to Kubernetes.